The last example you'll be working on today is taking a set of data and first of all identifying if it's quadratic, exponential, or linear, and then secondly writing an equation for it. And these are the equations that we're going to use. Quadratic, we're going to use y equals ax squared, where a is a value you're going to have to plug in and find. Exponential, we're going to use y equals ab to the x, where b is your common ratio, and then you'll have to plug in some values to find what your a value is. And then linear is y equals mx plus b. You'll remember that as slope-intercept form. So m is your slope, b is your y-intercept, and you should be able just to look at the set of data to find that. This is your common difference, and b is what's happening when your x is 0. But if you wanted to plug in some values to find those, you could. So let's look at our first set of data. And as you can see, as we're moving up on the x-axis, that this data is not going to have a common difference. You know, this is 2, this is 6, this is 10, this is, what is that, 12, no, 14. So we're not going to have that common data as you're going up. So we know it's not linear. Now we'll look and see that we have a difference of 4, difference of 4, difference of 4. Well, that was subtracting twice, and that fits with a quadratic. So in a quadratic function, we want to model this formula. Well, I don't know the a value, so I have to pick a point to plug in and find that, but I don't want to pick origin because 0, 0 is not going to help you. You could pick any other value that you'd like. So let's just pick this one. So 8 is the y, is equal to, I'm going to do some algebra to find a, negative 2 is my x. So 8 is equal to a times negative 2 squared is a positive 4, right? So we would just write 4a. When we solve 4a, we would divide by 4, and we get 2. Since our a is 2, I would write y equals 2x squared, and that is the equation for this function. If you would look, that a value had to be found by choosing a coordinate and plugging it in. So that's what you'll have to do whenever it's quadratic. Let's try another example here. Now we know it's not going to be quadratic because we just did that one. So let's see what's going on here. I know that this has a difference of 4, this has a difference of 4, this has a difference of 4, another difference of 4. That's only subtracting once. So this is linear. Now the linear equation, I think you can see this and this from my set of data here. I know that when x is 0, y is 3. Well, that's my y-intercept then. b is 3. And if you remember, the common difference is our slope. Our slope is 4. So we would have an m of 4. So I would write y equals 4x plus 3, and that's the equation for this function. Now, if you can't find the y-intercept and the slope from your set of data, then let me know and I'll help you to see those again, because it has been a while since we've talked about that. So that's how you would find a linear equation. So let's try the last example. Well, we did a quadratic, we did a linear, so this one has to be exponential. Just to prove that it is exponential, this is a timesing by 2, 3 times 2, 1.5 times 2. So this is a common ratio of 2. As you can see, as I'm moving up on the x here, this is times 2, times 2, times 2, times 2. I thought it was easier to see down here, that's why I focused down here. So I know I have a common ratio of 2. In my function, y equals a b to the x, b is going to be 2 because our base is the same as our common ratio. So I have y equals a 2 to the x. Well, to find a, we're going to do the same thing that we did last time. We are going to plug in an x and a y value. But this time it's okay to use what's happening at 0. That's okay to use in this case. Y is 3. I don't know a, that's what I'm looking for. 2 to the 0. Do you remember what anything to the 0 power is? Anything to the 0 power is 1. So this is just 3 is equal to 1 times a, which is a. So we just solved for a. So our equation would be y equals 3 times 2 to the power of x. We have to find a by plugging in a value into x and y. Your common ratio is going to be your b value. I think it's okay to pick what's going on at 0 because that would give you here a 1, which is going to be easier for you to solve. So try the example in your notes.